Hello, welcome back. Today in this tutorial, we are going to see how we can create an MCP server using Embabel framework. Using Embabel, we can create both type of applications, that is MCP server as well as MCP client type of applications. The focus of this tutorial will be mainly on creating the MCP servers. So before we jump into our coding part, let's quickly understand what exactly is the MCP server. So consider a scenario wherein you want to book a flight ticket and you are requesting your LLM application to do that. Now LLMs on their own simply can't book the ticket for you because LLMs can't interact with the real world. So that is where the concept of tools comes into the picture. Tools are nothing but the actual methods that can perform the action in the outside world. So let's say you have one tool which can book the flight ticket and your LLM application has access to that tool. Now when you send a request to your LLM application stating you want to book a flight ticket, your LLM application can make use of that tool to book a flight ticket for you. Now creating the tool for each and every AI integration can be cumbersome. That is where the concept of model context protocol comes into the picture. Using MCP, you can create the set of tools and make them available to any LLM which supports the tool calling. Now, the very first MCP server that we are going to build is the file operations based MCP server. Using this server, we can perform different operations related to files, such as creating a new file on our local system, reading an existing file, even we can overwrite an existing file, and also we can delete any existing file which is present on our system. So this is how our overall project structure will look like, wherein the name of our application is the Embabel MCP file server application. It is going to be Spring Boot based application. Now when it comes to the packages, we have different packages such as MCP package, inside which we have the file operations MCP class. This is the main class inside which we will create the tools that can be used by the LLMs. Then we have the DTO package containing two Java record files. These records will be used as the request that we will receive from LLM and also the response that we need to send to the LLM once the file related operation is completed. Then we have the config package within which we have one class configure open router models. Now when it comes to Embabel, Embabel needs at least one LLM model to be available. And in our case, we are going to make use of the free models that are provided by the open router platform. And inside this class, we will configure the free models that are provided by the open router platform. Then we have the normal Spring Boot main class. Then we have the application.yml containing basic configurations such as the application name and the default model which Embabel will make use of. And finally, we have the pom.xml containing the required dependencies. Now let's go through the different files that we have inside our project, starting with the pom.xml. Here at the very top, you will notice we are making use of Spring Boot version 3.5.8. When it comes to Java version, we are making use of version 21. And for Embabel, we are making use of the stable version 0.3.0, which is the latest version available at the time of recording this video. Now coming to the dependencies, in order to create the MCP server, we need the Embabel agent starter MCP server dependency, which will bring all the dependencies that are required to create the MCP server. Now in order to configure our AI model, we have added this dependency named as Embabel agent starter OpenAI, and we have added the Spring Boot starter actuator dependency. Now when it comes to our scenario, we are going to make use of the free models that are available via Open Router platform, and in order to configure that, we have added these dependencies because the models that are provided by the OpenAI are compatible with the OpenAI standards. That is where we have added the OpenAI dependency. And when it comes to the Spring Boot actuator, so this is required for configuring the observation registry, which we will see shortly. Now inside the dependencies management section, we have added the Embabel agent BOM, And when it comes to repository, we have added the Embabel snapshot and release repositories. Coming to the application YML, here we have configured the name of our application and we have configured the default LLM model, which is the Grok 4.1 free version available via Open Router platform. Coming to the Spring Boot main class, this is the standard Spring Boot main class that will boot our application. So now when we will start our application, Embabel expects at least one of the AI model to be available. That is where this class comes into the picture, configure open router model. Inside this class, we are configuring the different LLM models that are provided by the open router platform. So here you will see this class is extending the OpenAI compatible model factory because the models provided by the open router platform are compatible with the OpenAI standards. And here you will notice we are configuring the base path for open router platform. We have specified the chat completion endpoint. We have specified the API key that will come via the environment variable. Since we have added the OpenAI starter dependency, Embabel expect this environment variable to be available on startup. Inside this environment variable, we will specify the open router API key. Now, you might remember we have added the Spring Boot actuator dependency. This is where it is useful. So in order to configure the models that are compatible with OpenAI, we need the instance of observation registry, and this is provided by the Spring Boot actuator dependency. Now here you will notice we have configured few of the models using the bean of type LLM, and these are nothing but the free models that are offered by the open router platform. So one of the model you will notice is the Grok 4.1. So in order to create the bean of type LLM, we need to create the OpenAI compatible LLM. Inside this, we will specify the ID of the model from the open router platform. We have specified the pricing as 0.0 for input and output token since these are the free models. We have configured the provider as open router and we have configured the LLM knowledge cutoff date. So here you can create any number of bean instances for different type of LLMs. Now let's go through the main file of our application, which is the File Operations MCP. Now this class contains the set of tools that LLMs can make use of to perform any kind of operations related to the files. So let's go through this class. You will see we have defined the name of the class as File Operations MCP. Now, if you have been following the Embabel framework series, you might be already aware how to create an AI agent using Embabel. So the steps for creating the MCP server will almost similar. The only thing that will differ is we need to add certain additional attributes in order to mark our methods as the tools which LLM agents can make use of. Now let's go through the code that we have written for this class. At the very top, you will notice we have added the @agent annotation in order to mark this class as Embabel agent. Inside this, we have added the description stating an agent capable of managing file on the local file system. Now earlier we mentioned that we will be supporting four kind of operations. That is where we have defined the four methods: create file, read file, edit file, and delete file. Apart from this, we have defined certain utility methods or helper methods in order to work with the files. Now at the very top, you will notice the base directory wherein we have mentioned it as user.directory, which is nothing but the current working directory. So whenever we will issue the command to create a new file, it will be created at the root of this folder, which is Embabel MCP file server. Now let's go through our first method, which is creating a file. Now at the very top, you will notice we have annotated this method with @action annotation, which means the action that agent can perform. Then we have defined our final goal using achieves goal, within which we have added the description stating this will create a new file with the content provided by the user. Then in order to mark this method as the tool, we are making use of @export annotation. Here you will notice we have specified the attribute remote as true, which means this method or this tool can be used by the LLM whenever it will receive a request to create a new file. Then we have defined the name of the tool as create file. Then we have specified the starting input type as file operation request, which is nothing but the DTO that we have defined inside our application. Now, when we say starting input types, these are the starting input type for the goal, which Embabel can make use of to draft the prompt template. Now, if you see the file operation request DTO, here you will see we are accepting two inputs from the user. First one is the file name and another one is the file content. Now, whenever we have to create a new file on our system, user will provide the file name as well as the file content. Here you will see this method is accepting this as the input. Now, if we expand this method, this is nothing but the Java code that we have written in order to create a new file on our system. So here you will see first it is calling the helper method, which is defined at the bottom of this class resolve path by specifying the file name that we have received from the user. So it will first check if file with the similar name exists on our system. If yes, it will simply throw an error, and if file does not exist on our system, it will read the file content which is provided by the user and simply create a new file on our system using the files. So here you will see it will create a new file on the path which is our current working directory with the content that is specified by the user. And at the end it will simply return the file metadata. This file metadata is nothing but the DTO that we have defined inside our application. Here we have defined simple attributes like file name, exact path where the new file is created, what will be the file size, when was this particular file was created, when was it was last updated, what is the content of file, and if we will delete our file, in that case this boolean field will be set, and if there are any errors, the details will be present inside this field. So this is nothing but the simple Java code that we have written in order to create a new file on our system, and we are exposing it as the tool to our LLM with the help of these annotations and attributes. Now coming to the next method, which is read file. This is also similar, wherein we are trying to read the file which is present on our local system. So here you will see the name of the method is read file. It is expecting file operation request as input. Now in order to read the file, we only need the file name. So when LLM will make a call, it will only provide the file name. And once we have received the file name, it will search for the file inside the current working directory. If file is found, we will proceed. If file is not found, it will simply throw an error. And once the file is found, it will simply read the file content and return it back to the user by creating the object of file metadata within which we will specify the file content. Now here also you will notice the annotations are similar. We are exposing it as tool to our LLM with the help of @export annotations. Next we have the edit file. So here also you will see we have specified similar annotation. We are exposing it as tool using remote equals to true. Now in order to edit the file, we need the file name as well as the new content. So we are accepting similar DTO as an input request from the user, which will contain the file name and content. We are checking the existence of file. If file is available, simply override or throw an error. So when file is available, it will read the new content that user want to add to this file. Once we have the content, it will simply override the file content with the new content that is provided by the user. And once that is done, we are simply returning the response back to the user by specifying the new content that was provided by the user. Now comes the last method, which is delete method. The overall approach will remain the same annotation, same attributes. And in order to delete a file, we need the file name, which will be present inside this object file operation request. Using file name, we will check the file existence. If it is available, proceed with the file deletion operation or simply throw an error. Now, if the file is available, we will create the metadata object wherein we will set is deleted equals to true. Then we will delete the actual file and simply return the response back to the user. So this was the code that we have written for our file operation MCP server, wherein in order to perform any file related operation, we have written the Java code, and in order to expose them as the tools to our LLMs, we are making use of different kind of annotations that are provided by the Embabel. Now we have created our MCP server. Let's quickly test it by starting our application. So when we will start our application, we need to provide our open router API key. So if we will start our application, here you will notice the tools that we have defined are exposed by our application. So here it found the 4 goal tools and those are mentioned here. So now our MCP server is started. We need the client in order to test our MCP server. So there are two ways to test our MCP server. First one is using the MCP Inspector, which is the tool using which we can interact with the MCP server and test different kind of operation. Another one is we will integrate our server with the MCP client. In our case, we will make use of Claude Desktop application, which will interact with the file operation MCP server and perform different kind of operations. Now let's test our MCP server using one of the testing tools that is called MCP Inspector. For this, the Node.js should be installed on your system. In my case, it is already available, so I will directly run the MCP Inspector using command npx model context protocol /inspector. When we click enter, it will open the browser and run the MCP Inspector on port 6274. Now, in order to connect to our MCP server, we need to specify the transport type which our MCP server supports. So when we create the MCP server using Embabel, the transport type that Embabel support is the server sent events, and MCP supports different kind of transport as well, which is standard IO, and another one is the streamable HTTP. Now when it comes to the server sent events, in this case the server can send the events in the real time basis to the client. So in this case our MCP server can send the events to the MCP inspector using one long lived HTTP connection. So using this transport type, the bidirectional type of communication can happen, which means the MCP server can send the events to the MCP client, and even MCP client can send the events to the MCP server. And when we run our application, it will expose one endpoint which is /SSE, and MCP inspector will simply try to establish the connection using this endpoint which is localhost 8080 SSE. So when we click on connect, the connection will be established with our MCP server. So here you will notice client has requested the connection, and once the connection is established, you will notice the connected status is mentioned. Since we have created the tools that are exposed by our MCP server, we will go to the tools tab. We will click on list tools. Here you will see the name of the tools are mentioned: create file, read file, edit file, and delete file. So these are nothing but the names that we have given inside the annotation. For example, in case of create file, we have given the name as create file, and here it has prefixed the starting input type, which is the file operation request. So due to which you will see file operation request underscore create file, and description is the same which we have added here. So it says create a new file with specific content. Here you will see it says create a new file with specific content. Now when we click on this, here you will see it is accepting two type of fields. These are nothing but the fields that we have defined inside this particular DTO, file operation request DTO, named as file name and file content. Now let's say I need to create a new file with content as test content, and file name will be test file. So when we click on run, this request will be sent to our MCP server. The create file tool or method will be called, and it will create a new file named as test file at the root of our project. So when we click on run, here you will see the operation was successful, and as an output we were sending the file metadata as the response. So here you will see the file was created with name as test file. The exact path where the file was created is mentioned here. The other metadata attributes like created, add, updated, add are also mentioned, and the file content is mentioned as test content. Since there were no errors, the error field does not contain any value. So now if we check the root of our folder, the new file named as test file was created, and the content that we specified is also present here. And if you see the logs, here you will see the file operation request was received, due to which it is mentioned it as true, and then the create file method or tool was called, and it returned the response of type file metadata, which is visible in case of MCP Inspector. Similarly, if we have to read the file, since we have created the test file, I will try to read the file using read file tool. So it only needs the file name as the input. So we will specify the file name as test file. And if we send the command, here you will see the file content is mentioned as test content. Now if we specify any invalid name or invalid file name that does not exist, we will get an error. So here you will see the error field is populated, file not found. So here you will see the logs related to read files, like read file operation was performed, due to which it is mentioned it as true. Now coming to the third operation, which is edit file. Now we have the existing file named as test file. We will set the new content as test new content. Now when we click on run tool, it will simply perform the operation, and here you will see the content is mentioned as test new content. And if we go to our project, see the value present inside the test file, this is the test new content. Now let's test our final tool, which is delete file. So if you have to delete the file, we need to specify the name of the file, which is test file. When we click on run, here you will see the metadata which is deleted is marked it as true. And if we check our working directory, here you will see now the test file is deleted from our local system. So this is how we can test our MCP server using the MCP inspector. Now we will simply disconnect the connection by calling the disconnect method. Now another way of testing our MCP server is using the actual MCP client, which in our case will be the Claude Desktop. So we will open the Claude Desktop. Here inside the Claude, we need to specify the settings related to our MCP server, for which we need to click on Claude settings. And inside that, we need to go inside the developer option. We need to click on edit, and inside the Claude config.json file, we need to specify how we can connect with our MCP server. So at the very top, you will see the MCP server's root object. Inside this, we need to specify our MCP server. So we have given the name as Embabel MCP server. Then we need to specify the command and arguments how Claude Desktop can establish the connection with our MCP server. Here we have specified the transport type as localhost 8080/SSE, and these are the commands that are required to establish the connection to our MCP server. So once we have added the configuration inside this file, we need to save it, close this window, and we need to restart our Claude Desktop. So when you restart your Claude Desktop, it will, if everything is correct, it will establish the connection with our MCP server, and here you will notice the logs that are appearing. So here you will see the initialization request was attempted, and if we go to Claude Desktop, when you click on search and tools, here you will see the name that was given inside the config.json is mentioned here, Embabel MCP server. It is enabled, and when you click on this icon, here you will see the different type of tools that are exposed by our MCP server, like create file, read file, edit file, and delete file. Now let's test each of these operations. So I'll send the request for create a new file on our system. Create a new file. with name test file.txt, and the content should be hello world. So when we will send the request, the Sonnet 4.5 will make use of our tools that are exposed by our MCP server and simply create a new file. So here you will see it is asking the permission whether can I make a call to the file operation request create file with this kind of content, like the file name is testfile.txt and the file content is hello world. If we will allow, it will simply call our tool and create the new file. So here you will see the operation was successful, and the metadata which was written by our MCP server, the Claude made use of that and simply printed the metadata here. So now when we go to our system, here the new file with name testfile.txt is created and the content is mentioned it as hello world. Similarly, if we have to override the file content with some new content, we will simply say um, edit our file with name testfile.txt and with new content as test new content. So now it will make a call to our edit file operation. So here you will see it is trying to call the edit file tool with new content, and the file name which we need to edit is testfile.txt. So if we will allow, it will simply call our tool, and once our file is updated, we will receive the new metadata which is printed here. And if we go inside the IntelliJ, here you will see the file content was updated with the new content. Now let's test the final operation by asking the Claude Desktop to delete the file. So it will simply call our delete file operation tool, and it will try to delete our file which is available inside the working directory. So here you will see it is trying to call delete file, and since only file name is expected to delete the file, it has populated its name as testfile.txt, and if we click on allow, it will simply delete our file. And here you will see the status which was received was is deleted true, and if we check our working directory, test file was deleted. Yeah, so that was all regarding how we can create the MCP server using Embabel framework, how we can test our MCP servers using the MCP Inspector, as well as the actual MCP client which is Claude Desktop. And we have also written the detailed blog on it. So if you are interested, you can go through the same. Also, the code that we discussed during this tutorial is uploaded on GitHub. You can check out the code, set your open router API key and test this file server MCP. Yeah, so that was all from my end. I hope you found it useful. Thank you.